Continuing on with our law of cosines, this is a fun case because sometimes they're going to give us all three sides of a triangle. Now, if they give us all three sides of a triangle, we have to use law of cosines because law of cosines doesn't require us to have an angle. Where law of sines, you have to have at least one angle. So if they give you three sides, because let's take a look at that. What is that going to look like? Let's go ahead and draw this triangle. Let's draw a triangle ABC, and the big A, the big B, and the big C are all corners where little a, little b, little c are the sides opposite those angles. This is a bigger C. Boom. We are told A is 9.47, B is 15.9, and C is 21.1. So what we're noticing is that there is no angles. Because remember, law of sines would have sine A over little a and sine B over little b. You'd have to at least know one angle. But we can find an angle if I'm given all three sides. We saw that, I can take the law of, we saw that I think in the last video, or in the very first video with example 1. What we can do is we can find an angle if I know all three sides. So let's find the cosine of angle C. Why C? Why not C? That's why I just picked one. So the cosine of angle C is going to equal, we figured this out in the first video again, a squared plus b squared minus c squared all over 2 times a times b. We know the length of side A, the length of side B, the length of side C, and that'll let us find angle C. So I know the cosine of angle C equals little a squared, 9.47 squared, plus 15.9 squared, minus 21.1 squared, all over 2 times a, 9.47 times b, 15.9. So I'm going to bang all of this into the calculator, and that we're going to find out that cosine of C gives me about negative 0.3410940208. And then we're going to take the inverse of this to find out that C is about 109.9 degrees. Now, we can do a couple things at this point. We can continue working with the law of cosines, and we can find our other two angles, or at least one more angle, or we can use the law of, now we can choose, we've got an angle, so we can use the law of sines. Well, since we're working with the law of cosines, I'm going to keep using the law of cosines, and this time I'm going to find angle B. So the cosine of angle B is going to be, well, the same formula, except now B is the known side, so we're going to say a squared plus c squared minus b squared all over 2 times a times c. And why the b and the c switch places is because now we're looking for b. So the cosine of angle B is going to be 9.47 squared plus 21.1 squared minus 15.9 squared all over 2 times 9.47 times 21.1, my C. All of this gets entered into a calculator, and we find out that the cosine of B is about 0.705848101. Take the inverse cosine for this, and we're going to get that angle B is about 45.1 degrees. Now, what we want to do instead of using the law of cosines to find angle A, because inevitably what's going to happen is we're not going to quite add up to the 180 because of the rounding. Let's just jump right in, and we're going to say A plus B plus C equals 180. Well, we know B and C So A plus 45.1 plus 109.9, that's going to equal 180. And we finish, so that's going to give us, add these together, A plus 155 equals 180. Subtract 155 from both sides, and we're going to find out that A should be about, and it's going to be an about because, again, B and C are rounded, so A is going to be about 25.0 degrees. And I know that when you put this into Canvas, it's going to knock off that 0.0, but what I like to show is that my answer is accurate out to 1 decimal place. That's why I am showing that. So, of course, once I had found one of the angles, I have to use law of cosines to find an angle. Once I find one of the angles, I could have jumped on law of sines, but I wanted to work with you to reinforce the law of cosines. But don't be constrained to just one way. Remember, the tools that we already have in our box are still good tools. Use them. So now we are specifically told, here is, we are designing a roof truss. And I know all the board measurements to make that truss, but I don't know this angle here when I'm setting it together. So let's find that angle. Well, we've already discussed this. We know the cosine of angle B, the angle I'm looking for, equals A squared plus C squared, the two sides that are not associated with B, minus the side opposite of B, all over 2 times A times C, the sides that aren't B. Alrighty, so let's plug in our values for A, C, and B. So the cosine of angle B is going to be the side opposite of A. So there's my little A, there's my little B, there's my little C, because they are all opposite of each other. Is going to be 11 squared plus 9 squared minus 6 squared. It's important that we know which ones are A, B, and C, because one of them will be subtracted and one of them is not on the bottom. I need to know which one's which. It's important to know which one is B, because that's the one opposite. I'm going to plug all of this into my calculator just like it appears right here. I am not going to do it by parts. Have my calculator do all the heavy lifting for me. So when this works out, I get 0.83838383884. Boom. And I take the inverse so I can find out what B is about, and B is going to be about 33.0 degrees. Boom. And that is how we can use the law of cosines to find an angle given all three sides. So if we have one more example to do from this lesson, I'm going to do it on a video by itself. It won't take very long. That one will be super short. So you got that to look forward to. So if you have any questions, please come in with those questions. I will gladly go over them in class. So I will see you when I see you, gauchos.